This is a very brief explanation of the Jupyter paper concepts. So how do we usually submit our papers? Well, usually we submit a PDF file with paper text and paper figures, and then sometimes we also add a code as a supplemental material. What we did here, however, was that we made a single document in the form of Jupyter notebook that contains paper text, paper figures, and executable code that allows reproducing all the results from the paper. So this is a kind of hybrid paper that has both classical paper features and also contains an executable code. And so this is how it works. For now, we publish it as a mirror paper on the preprint server. It needs to be opened in a Google Colab, which is a free tool for machine learning research and education, which requires no setup to use. So now we opened it in Google Colab. We can actually make it black font on white background, so it will look more like a classical paper. All right, and so what you see here is a classical paper organization. We have abstract, introduction, results and discussion. We have figures, obviously. We have conclusions, acknowledgements, references. But, so the code sections appear hidden by default when viewed in Google Colab, but we can actually unfold them. And then we can run the same code that was used to produce this paper's results. So we can repeat all the steps that the authors, in this case us, did when they wrote the paper. So we start with loading some basic custom modules and checking that all the necessary things are installed. And it takes maybe about 20 to 30 seconds. All right, and now we import all the modules that we'll need to run this notebook. All right, we can hide this code again. So now we can proceed to a section where we did image processing with deep learning. And we have two additional subsections here. And one is neural network training, which you can actually do in Colab because Colab allows you to use a free GPU for 12 hours. So you have GPU support here. But we also provide an already trained model, and therefore you can skip this section. And you can go right to inference on the experimental data section. So here we load the neural network, which is provided together with this notebook, a trained deep learning network. And then we can specify the name of the file that we are going to work with. So it's a experimental image from scanning transmission electron microscope. And here we pass this image through a neural network and get prediction. And then we plot the results. And this will be the results that we actually used in figure 1 of our paper. So this is original experimental data and the output of a neural network. And then we proceed to some other type of analysis, which we had in our paper, like principal component analysis, non-negative matrix factorization, and so on. And at the end, you can actually download. So this notebook is running in the cloud. It's free, but it runs on the cloud. So we actually need to download the results to our local machine. Otherwise, the results will be lost. So all the results that we generated when running this notebook will be downloaded to a local machine. So this is how it works.